So let's take now our next problem on heights and distances, where we'll apply the properties of 45, 45, 90 and 30, 60, 90 degree triangle. Okay, so let's understand what is being given here. This problem was asked in CAT 2003. Okay, so let's understand what is being given here. A vertical tower OP stands at the center of a square ABCD. Let H and B denote the length OP and AB respectively, and angle APB is 60 degree, then the relationship between H and B can be expressed as, okay. So I would rate this problem to be as difficult. Okay, the reason for that being is simple, because you may not make the correct diagram here. Okay, you may end up making a wrong diagram and you may not get the answer. So making a right diagram is a key here. Okay, that's why I would rate this problem as difficult. So one of the problem, if you are not able to get in the paper, it would be this. So let's try and solve this. Okay, so there is a square, as I understand, there is a square that is ABCD. So I'll make a square here. There's a square ABCD. And what is being given here? Vertical tower OP stands at the center of the square ABCD. So if this is a square, and if I am drawing the diagonals of this square, so one of the diagonal is like this, and the other diagonal that I draw would be like this. Right, so this would be the two diagonals of the square, and if I make their size as same, that is how it would be. Okay, now with this, can you realize some of the properties of square? Okay, can you remember some properties of square that you can apply to this? What do you know about the diagonals of a square? The diagonals of a square always bisect at 90. There are two such figure where it happens in this way. One is a rhombus, other is a square. Okay, so I know that the diagonals bisect at 90. So this angle would be equal to 90 degree. And this is the center, that is O. So a vertical tower OP stands at the center. So this tower, if I bring this tower here, this tower that is OP stands at the center. So if I say this is O, this is P. This tower stands at the center of the square. So it is exactly here. From this tower is being erected. Okay, so imagine it's a 3D figure. The square is at the bottom and the tower goes up, okay, from the center. So you have to imagine it as a 3D figure, then only you will be able to solve it correctly. So vertical tower OP stands at the center of the square ABCD. Let H and B denote the length OP and AB respectively. So H and B, H is OP, so I know that this length, the height of the tower is equals to H. Get this one. And B denote the length of AB. Okay, so if I'm calling this as ABCD, so what will be AB now? AB is equals to B. So I know that this length of the side of the square is equals to B. Okay, that's how you can put it in the right way. What else? Angle APB. Now imagine what is this. Okay, this is where you can get it wrong. Angle APB, which means this bottom of the square, this A, is being connected to the top of the tower like this one. And then this top of the tower is connected to the second corner of the square, that is B, and this angle is equals to 60 degree. That's how you have to visualize this. Okay, so it's from the bottom. So there's a square, and from the bottom you take two of the sides in this way, and it is connected to the top of the tower. Okay, so visualize it correctly. This angle is equals to 60 degree at the top. The square and two corners tied to the top of the tower. Okay, that's how it is going. So from this I understand this as well, that this angle is 60. From this I get one more thing. Now imagine if there is a tower at the center, okay, and you are bringing one of the, say, rope from here, which is being tied like this, and you are bringing the other rope here, which is being tied like this. So the length of this both has to be equal, right? Because it is at the center. If it was here and there, then it would have been problem, but it is exactly at the center. Check it. It is at the center of the square. So length of this has to be equal to length of this. Okay, that is quite logical. because this is center and I bring one rope from here and I bring one rope from here. This is exactly at the center. So length of this and this rope has to be equal. Okay, that is quite logic. Which means what? This becomes an equilateral triangle. Okay, because I know one of the angle is 60 and this two length has to be equal. So this becomes equal to 60 and this becomes equal to 60. Okay, that is how you have to visualize it correct to reach on to the answer. That's why I said this is a difficult problem. Okay, if you don't visualize it right, you may not get the answer. Now let's solve this. So what do I know? First, let me think of this green triangle, okay, which is this one. Okay, what do I know about this? It's a 45, 45, 90. How do I know that? Because one of the angle here is 90. The diagonals of a square bisect at 90. And I also know that what this two has to be equal. The diagonals of the square are equal. Even if they bisect, still they are equal, right? If this is 10, they will be bisected into 5 and then 5. So they have to be equal. So which means this becomes a 45, 45, 90 degree triangle. So I would say this is 45 and this is also equal to 45. So this becomes a 45, 45, 90 degree triangle. What do I know about this type of triangle? The sides of this triangle 45, 45, 90 are in the ratio of 1 is to 1 is to root 2. So what do I know? I know root 2 is equals to b. Okay, so the other two sides will become what? See, if this is equal to b, so how can this becomes b? When you multiply this by b by root 2, it is only then you can say that this will become b. So this will become b by root 2 now. This will become b by root 2 now, and b by root 2 into this will become b. This is b only. So from this only I got this. So as I said it earlier, if you know one of the sides in a 45, 45, 90, you can find the other two sides. That's what I did here. Okay, so this side becomes equal to b by root 2. Okay, so this is also equal to b by root 2. They are one and the same. So I know this. Okay, that is the first thing. What else do I need to know? Now, once I get this, I'll go with this. What is being asked? What is the relationship between h and b? Okay, so let me rub this now. And I'll start with a different triangle here, which is triangle APB. I know that's an equilateral triangle. Okay, so what can I think of here now? Nothing much possible. Okay, so let me think of one more triangle, which is this. Okay, now think carefully here. I am joining this. Okay, this is nothing but the height of the tower. So I am just joining that. Now, what will be this angle? You think of this angle. This angle has to be equal to 90 degree. Now again, you have to visualize this in a 3D. This is a tower and this is how the square is coming, right? So that is why I say that that angle which I am talking about here, this has to be 90 degree because the tower is like this and it is coming like this. So this angle, if I show it in this way, this would be 90. Okay, because the tower is perpendicular to the ground. Okay, that's the case. So this angle becomes equal to 90. Okay, which is what I know it here. So I am talking about which triangle now? See, visualize this in a 3D. Okay, I'm talking about this triangle now. This one. This entire triangle I'm talking about, which I had painted it in red. This one. This triangle I'm talking about. So it is like this. The tower is here, this is here, and then there is one more length which is going on like this. Okay, so this is how the triangle is in a 3D. That is why I say that the bottom angle would be 90. So now I can apply the Pythagoras theorem here, okay, which is what? AP square, okay, side opposite to hypotenuse, that is equal to what? That is equal to b. Okay, because this is an equilateral triangle. This one, this is an equilateral triangle, so all the three sides would be equal to b. Okay, so this is equal to b now. So once I know this is b, so let's put this afterwards, but I know this is AP square is equals to what? Is equals to your this AO square, okay, which is this one. Is a right angle triangle, so AP square is equals to AO square plus PO square. Right? Understand this to be a right angle triangle, which I showed it to you like this. So this side square, that is AP square, is equals to AO square plus the height, okay, which is PO square. So that's what I write it here. So AP square is equals to AO square, okay, plus OP square. Now, what do I know from this? I know that AP is equals to B, so B square is equals to AO. AO is equals to B by root 2. I already know this. Okay, I found this out at the start only. This is B by root 2. So I'll substitute this as B by root 2 the whole square plus OP. OP is what? The height of the tower. That is equal to H. So I know this B by root 2. I know this H and I know this as B. So I'll write this as what? Plus of OP, that is equal to H square. They wanted the relationship between B and H. I have a relationship between B and H. Okay, now let's just solve this. So this becomes B square is equals to B square upon 2, okay, plus H square. If you just take the B there, that will become B square minus B square. So this becomes half of B square, okay, is equals to H square. So what do you get here? You get B square is equals to 2 of H square. Okay, that is what is the answer that you get in this case.